Before time itself existed, there was nothing. No space, no light, no sound. Only absolute silence, compressed into a point smaller than a speck of dust. Then, in a fraction of a second, the impossible happened. Darkness tore open. From the void emerged energy, and from that energy, the universe itself was born. In less than an instant, reality came alive, expanding in every direction, as if the cosmos had just awakened from an eternal dream. This was a theory not imagined by a mystic or a dreamer lost in delirium, but by a priest. Georges Lemaitre dared to see the universe not as a static cathedral of stars, but as a cosmic seed that exploded into existence from a single point. An idea so bold that even Einstein called it abominable. But what emerged from Lemaitre's equations wasn't just a new theory, it was scientific heresy. An idea so contrary to everything physicists believed that many treated it as a joke. After all, how could the universe have a beginning? To the scientists of the time, it sounded more religious than rational. And that's how one of its harshest critics, astrophysicist Fred Hoyle, mocked the hypothesis on the radio, calling it the Big Bang. A name spoken with irony, meant to ridicule the concept of a cosmos born from an absurd cosmic explosion. But the ridicule didn't last. Decades later, evidence began to line up, and that joke became the most accepted theory about the origin of everything. The Big Bang isn't just the start of space and matter. It's the moment when the very laws of physics collapse. A moment when time itself was born, and everything before it remains shrouded in the same mystery that gave rise to the cosmos. For centuries, it was believed that the universe was eternal, unchanging, infinite, a static stage where stars simply shone without beginning or end. This was the prevailing scientific conviction, reinforced by Einstein's theory of relativity, a masterpiece that seemed to close the door on any other idea. But in 1927, Georges Lemaitre shattered that certainty. While scientists sought stability, he saw motion in Einstein's equations. And with boldness, he imagined all galaxies moving away from a single point, a primordial atom, infinitely dense, from which everything had emerged. It was a radical idea, one that challenged not only the concepts of space and matter but the very notion of eternity. If the universe had a beginning, then all the known rules of physics had a starting point. Time, space, and energy, all created in an instant that still defies human comprehension today. What began as a provocative idea, dismissed by many as absurd, opened the door to a new universe of discovery, from Hubble's observations to cosmic microwave background radiation, and even the modern theories of Hawking and Penrose. If the universe was born from a single point, the inevitable question remains: what existed before that instant? Embrace the mystery. The universe still holds secrets about the very moment everything began. In 1927, through the quiet corridors of the Catholic University of Louvain, the echo of solitary footsteps cut through the silence. Georges Lemaitre, a young priest and physicist, walked beneath vaulted ceilings, lost in thoughts that stretched far beyond the candlelit chapel. While the scientific world buzzed with Einstein's relativity and the first glimpses of quantum mechanics, Lemaitre pursued something even more fundamental: the very nature of the cosmos. To him, the universe was not just an equation to be solved. Every star, every atom, spoke of order and balance, and everything could be measured. Night after night, he filled notebooks with calculations that seemed to breathe with a life of their own. While nearly every physicist believed in an eternal, unchanging cosmos, Lemaitre saw a pattern that could not be ignored: space was expanding. Galaxies were not static points. They were moving away from one another, like marks on the surface of an inflating sphere. He imagined time in reverse, rewinding the expansion. Galaxies collapsing toward a single point, stars folding into energy, everything converging into one primordial atom. Not an explosion within space, but the creation of space itself. Lemaitre had crossed a boundary no one had dared to cross before, a universe with a beginning, a singular point of infinite density and unimaginable heat. For him, this discovery was not heresy, it was harmony. The mathematics of creation revealed what faith had long intuited, a cosmos born from a singular moment of creation. But to the scientific community of the time, this vision was revolutionary, almost impossible to accept. The world wasn't ready for this idea, not even the scientists in charge of it. For centuries, the universe had represented permanence and stability, eternal, silent, unchanging. Even Einstein shared the vision of a fixed, balanced space, like a vast cathedral suspended in time. The idea of a beginning, of the cosmos having a birth, was not just controversial, it was offensive. Then came Georges Lemaitre, the quiet priest who dared to suggest otherwise. But his revelation did not earn applause, it ignited an intellectual war. Across the English Channel, Fred Hoyle, one of the most influential astronomers of the era, defended the old cosmos, a steady-state universe, always present, continuously creating new matter to fill its void. To Hoyle, Lemaitre's proposal was not science, it was superstition dressed in mathematics. In a BBC radio broadcast, Hoyle mocked the idea, using the term Big Bang in a pejorative sense. He intended ridicule, but inadvertently gave the theory the name that would immortalize it. Even Einstein hesitated. When he reviewed Lemaitre's calculations in 1927, he nodded and said, "Your mathematics is correct, but your physics is abominable." For a time, the idea of a beginning was rejected, the eternal universe remained dogma. But nature itself could not be silenced. Distant galaxies, observed just a few years later, began to reveal cosmic expansion. Mathematics and observation walked hand in hand, and the theory once ridiculed slowly edged closer to the truth. High above the haze of Los Angeles, on the lonely summit of Mount Wilson, the night sky stretched out like a silent ocean. It was the late 1920s, a time when every telescope was still a portal into the unknown. And before the largest of them, a man prepared to record the cosmos like never before. Edwin Hubble, an American astronomer with the patience of a monk and the curiosity of a child, trained his instrument on the faintest specks of light scattered across the darkness. For centuries, these specks had been dismissed as mere clouds of gas within the Milky Way. But Hubble saw something extraordinary, entire galaxies, each containing billions of stars, and all of them moving away. The light reaching his telescopes carried a coded secret, a redshift. To the layperson, just a color; to a physicist, a message from the very fabric of the universe. Just as the pitch of a siren drops as it moves away, light stretches, its wavelength increasing, turning red, the Doppler effect applied to light. Hubble measured galaxy after galaxy. Each carried the same signal, none were standing still. The farther away, the faster they were moving. These weren't just stars traveling through space, it was space itself expanding. When these measurements reached Europe, they reverberated like thunder through the halls of science. Georges Lemaitre's primeval atom, once considered poetic fantasy, gained observational support. The universe, just as he had predicted, was expanding. Einstein, who had resisted the idea of a beginning for years, revisited the data. In silence, he admitted, "Now I see the necessity of a beginning." This revelation changed everything. Science could no longer cling to eternity. The stars were telling a story of origin and motion. Every atom, every planet, every life traced back to a primordial instant, the starting point of space, time, matter, and energy. Lemaitre's vision prevailed. The universe was not static. It was alive, breathing, in constant evolution. But with this truth came an even greater mystery, one no telescope could capture. If we can track the expansion, we still don't know exactly how it all began, what that very first moment really was. Einstein had always believed in an eternal universe, calm, self-contained, governed by elegant equations that never began and never ended. But now, his own mathematics betrayed him. An expanding universe carried an impossible consequence, an absolute beginning. And beginnings are chaotic. For Georges Lemaitre, this was not merely a poetic metaphor. He called this instant the primeval atom, a cosmic seed so small the human mind can barely grasp it, containing all the mass, energy, and time the universe would ever hold. A point of infinite density, smaller than a speck of dust, where volume approaches zero and temperatures exceed any imaginable scale. But here's the problem: at this point, physics simply breaks down. The laws governing gravity, matter, and motion lose all meaning. Equations become useless, numbers meaningless. It's as if reality itself refuses to be deciphered. Where everything becomes infinite, science loses its words and tools, the universe closes the door on direct observation. To escape this mystery, modern physicists developed the idea of cosmic inflation. According to this theory, in the first trillionth of a second, the universe didn't just expand, it exploded exponentially, growing faster than the speed of light and creating an improbable uniformity across the cosmos. Tiny quantum fluctuations were stretched, forming the seeds of galaxies we would see billions of years later. And then, as mysteriously as it began, inflation ended. Energy cooled, condensed, and transformed into matter, light, stars, and galaxies, all in an unimaginable instant. In the blink of an eye, the universe went from invisible potential to visible creation. For the first time, humanity could describe the first fraction of a second of the cosmos, the birth of everything we know. Yet an impossible question remained: if time, matter, and energy began with the Big Bang, then, if the Big Bang wasn't the very beginning, what existed before it? In 1981, the marble halls of the Pontifical Academy of Sciences in the Vatican were thick with silent anticipation. The world's greatest cosmologists had gathered beneath ceilings adorned with centuries-old frescoes to tackle the oldest question of all: what came before the beginning? Among them, seated in a wheelchair, was a man whose mind raced faster than any light: Stephen Hawking. His voice, amplified by a synthesizer, carried the weight of modern physics. As he began to speak, the room fell silent, aware that what was coming could redefine the very notion of creation. Hawking presented his no-boundary proposal. According to him, the universe is finite but without an edge. Imagine the surface of the Earth. You can travel in any direction, but you will never encounter an end, only curvature. Reach the South Pole, and there is no further south. The very concept of direction ceases to exist. Hawking suggested that time works the same way. At the Big Bang, there is no before, not because it is hidden, but because it simply does not exist. Time itself begins there, just as latitude ends at the pole. Asking what happened before the Big Bang is like asking what lies south of the South Pole. The question loses meaning. This idea united science and philosophy in a way never seen before. The Big Bang did not merely mark the appearance of matter in space, it was the birth of time itself. Space and time, matter and energy, all emerged simultaneously, as if the universe had taken a single, collective breath of existence. The vision was serene and logical, yet profoundly humbling. The universe, finite but boundless, existed on its own, without a before, without a temporal cause, simply self-contained existence. Still, not everyone accepted that the trail ended there. Some physicists, restless and daring, refused to believe the Big Bang was the final act. For them, the curtain of time might only mark the beginning of something even deeper, a mystery that challenged even the brightest minds. But some dared to imagine what could exist beyond the beginning of time. Beyond the edge of the known cosmos, where equations falter and imagination seems to touch infinity, a new generation of physicists began to ask, what if the Big Bang wasn't the beginning of everything? Some proposed that the universe never truly begins, it cycles. Like the rhythm of a cosmic heartbeat, it expands, slows, collapses, and is reborn again. This is the idea of the Big Bounce. With each contraction, all matter and energy compress. With each expansion, new stars, new galaxies, new worlds emerge. Time has no absolute beginning or end, stretching infinitely in both directions, like an eternal inhale and exhale of eternity itself. Others looked even deeper, at the silent traces left by existence. Sir Roger Penrose, a mathematician of extraordinary vision, proposed conformal cyclic cosmology. According to Penrose, when a universe cools and empties, when black holes evaporate and matter disperses into radiation, the cosmos transforms almost imperceptibly. The frozen vastness stretches until its dimensions lose meaning, and from this spectral silence, a new universe, a new aeon emerges. In this model, there is no first or last universe, only an infinite chain of rebirths, each aeon carrying subtle imprints of the previous one. Penrose suggests that these cosmic fingerprints may still be detectable in the cosmic microwave background, the residual glow of past creation, echoes of universes that once were. Then come the theorists of higher dimensions. Edward Witten, through superstring theory and M-theory, expanded reality to as many as 11 dimensions, imagining a cosmos where our universe is just a membrane, a brain, floating in higher dimensional space. The ekpyrotic model proposes that the Big Bang we know occurred when two such brains collided, releasing unimaginable energy and creating the matter and space we inhabit. Each collision is merely another chapter in a far grander, multidimensional cosmic story. In these visions, the cosmos has no definitive beginning or final end, only transitions, transformations, and rebirths. The Big Bang ceases to be a singular birth and becomes merely a page in an infinite chronicle, written and rewritten eternally, with each universe arising from the ashes of its predecessor. And if these ideas are correct, then everything we see, the light of our stars, the shape of galaxies, even the atoms that make up our bodies, has already happened countless times before. Each atom carries the history of past universes, each photon, echoes of eras repeating. What if everything we see has already happened before? What if the universe is simply an endless dance of beginnings and endings, rewriting the story of creation with every cycle? From the glow of a candle in a chapel to the echoes of colliding universes, our search for beginnings has carried us through centuries, yet we arrive at the same point. Where did it all begin? Every answer we uncover opens 1,000 new doors. Equations that once promised clarity now reveal even deeper shadows. Every discovery, no matter how brilliant, only intensifies the mystery. Perhaps this is the greatest beauty of the cosmos, it will never be fully known. We measure, we calculate, we imagine. We observe distant galaxies, trace photons that have traveled billions of years, reconstruct the universe's story second by second. And yet, beyond the horizon of physics, there is something no telescope can capture: the quiet humility of not knowing. Perhaps the Big Bang was not the absolute beginning, but merely the first page we are able to read in a book that stretches infinitely, existing before time itself. Perhaps the universe is an endless cycle, one aeon following another, a dance of beginnings and endings, birth and death, each iteration more complex, each one more silent. And even when we trace the lingering glow of creation, when our theories reach the instant before time, the question, why, remains untouched, shimmering just beyond our understanding. Throughout this journey, it is important to remember that everything we present is based on reliable scientific research, but some scenes and passages have been crafted narratively to illustrate complex concepts, bringing life and clarity to what is often almost incomprehensible. The goal is to educate and entertain, bringing every viewer closer to the vastness of the cosmos. And so we continue, scientists and dreamers, priests and poets, all gazing at the same sky, all seeking the same origin. Perhaps the universe is not a puzzle to be solved, but a story that never ends, a cosmic symphony without a first note, where science and wonder coexist in perfect harmony. In the end, every question we ask about the universe is also a question about ourselves, our curiosity, our imagination, our desire to understand something greater than we are. Perhaps the universe never began. Perhaps it simply remembers. And if you felt the grandeur of this story, if you marveled at every discovery and every mystery, like, share, and subscribe to the channel, because the journey through the cosmos is infinite, and every new video is another page in this book that never ends.